Hello everyone, you welcome to my class. I hope you are doing well. Today we are going to study chapter number 2, matter and measurement. Let's see. And before starting our lesson, I want to just remind you something that we learned last week. Do you remember what we studied last week? Yes or no? Who remembers? Okay. Remember, last week we studied history of physics, and we studied history of some of the scientists in European world and in the Muslim world. You remember, right? And we also defined physics. What was the physics? Do you remember? Who remembers? You? Okay, very good. Well done. It is one of the branches of physics one of the branches of science which explains energy, matter, and the relationship between them, right? Okay, very nice. And now let's start matter and measurement, chapter number 2, everyone. Guys, we see most of the things around us. We cannot see some things. For example, we see this pen. We can see the book. We can see for example, the set of masses, but we cannot see, for example, air. We cannot see light. We cannot see, for example, heat, right? When our body is heated, we cannot see, right? If I ask you what is the matter, what will be your answer? What will be your answer? Anything which has mass, just mass, value. Okay, very nice. Oh, that's right, guys. That's correct answer. As you know, anything which has mass and value around us can be defined as matter, right? Anything which has mass and value. That's very important. Okay, anything matter can be defined as anything which has mass and value. For example, rock, for example, pen, for example, water, for example, lake, everything which has mass and value. Okay, for example, this pen has mass, right? We can calculate its amount. And it also has value. And this pen occupies space in the air, in the classroom. Human body, for example, covers volume in the classroom. And we also, as beings, have weight, mass. So human also what kind of matter? For example, this book covers what space in the classroom, and it has a mass too. So it's a kind of matter. Most of the things you see in the classroom just is matter, right? Let's look at this picture and tell me the examples of matter. What do you see in this picture? What do you see? Ego? Okay, is the ego matter or not? What do you say? Matter? Yes. Why? Because it has mass and it covers what? Space, right? How about fish? Fish is matter or not? What do you say? Matter? Very nice. Of course, matter, because fish cover what? Space in the water, or let's say in the air when the fish jumps, right? It covers space. It means it has value and it has what? Mass too. So fish also kind of matter. How about water? Of course, water is covering space, right, in the earth, so it is also kind of matter. Let me ask you one more question about matter. Is the air matter or not? What do you say? What is your answer? That's correct. Very nice. Of course, it is what? Matter. How do you know? Taking break? Very nice. When you take a break, for example, your chest is getting a little bit larger. So air is kind of what? Matter. We are going to do experiment about this one. I am going to show you demonstration to know whether air is matter or not. You know, we cannot see air, right? We can just feel it when we take a break, right? So air is matter, of course, but we are going to just see whether it is matter or not by doing experiment. Okay? Let's do experiment, everyone, together, and let's see whether air is matter or not. Okay, I am going to use some tools, for example, ruler. I'm going to use ruler to balloons, everyone, you see, and a kind of thread I am going to use. Okay, that's the first. Let's blow the balloon, both balloons, but their sizes must be same, otherwise we cannot find the balance. Okay, let's blow the balloon. I think this size is enough, everyone. And tie its mouth and okay, and tie it with thread, guys. And yes, this is the first one. Okay, let's blow up second one. Let's blow up second one. Be sure that their sizes are same. Let me check. This is a little bit large. Okay. Okay, good. That's okay. Now, just wait a minute. Okay. It is a little bit thin rope. Okay, now guys, I'm going to put this ruler on the wooden block, but be sure that both sides are same in length, otherwise it will not be in balance. Okay, and now it is in balance. Okay, let's tie one of them to one side. One side of the balloon. Another one to other side. Yes. Let's see. Just wait a minute. Okay, now guys, you see both sides in balance, right? Okay, now you see balloons are in balance, system totally is in balance, and now I am going to burst one of them to see whether the system will be in balance or not. Let's see. Okay, for example, I am going to burst this one. This shouldn't be moving, guys. Let's see. Okay. As you can see, this side is going down. We need to just put it like that. One side, right side is going down. Why? Because guys, we burst one of the balloons which was on the left side, and it was including air particles. It means the mass of air molecules, air particles on the left side, just making the system, just bring system in balance. But if we burst one of them, so the system just went down and system is disturbed. Okay, the balance is disturbed. So we can say, guys, air is a kind of matter, because air just has weight, particles, right? So it is matter. Let's look at another demonstration, guys, to see whether the air is matter or not. And this is guys, beaker. This is beaker, and we have some water. We filled it with water, and now I have a glass, guys, empty glass, and I have a paper piece like this one, and now I am going to crunch up this one like this and put it into the empty glass. Yes, and put it to the down. And now I am going to turn glass upside down and invert it into water. Let's see, and we will see whether the piece of paper will be wet or not. Okay, let's see. And take it out and see whether it is wet or not. Okay, as you see, guys, this is not, it is dry, right? It is totally dry. Why? Because this one was at the bottom of at the bottom of glass, and some part of glass was filled with air. Okay, air pushed the water down and took some space in the glass. It means air is a kind of matter. Okay, that's it about the air, guys. Let's continue. Okay, let's continue, everyone. Okay, let me underline this part, guys. So we just define matter as anything which has a mass and value. If you see something which has mass and value, it is exactly kind of matter. Okay, now we can say, guys, even something that we can't see can be matter. Okay, let's continue. Okay, let's some of the things we see us, guys, cannot be matter. Why? Because maybe they don't have mass and value. For example, light is not matter. Sound is not matter. Heat is not matter. Why? For example, guys, light coming from the sun passing through the space. So it doesn't affect the space. It directly comes to our Earth and passing through the space and atmosphere. Light is not matter. How about the sound? Sound. Is my sound matter or not? What do you say? Yes or no? Of course, it is not matter, because my sound is transferred to your ear by what? By the vibration of the air particles. Okay? So without our air particles, guys, you will not hear my sound. Okay? You will not hear any sound. You hear because of what? Having air particles. Okay? Heat also not matter. You, for example, when sun heats your body, do you feel yourself a little bit lighter or heavier? No, right? So we can say heat is not matter. Okay. Campfire also kind of heat, so it is not what? Matter. Okay, let's continue. States of matter, everyone. You know, everyone, there are three states of matter: solid, liquid, and gas state. There is another state actually, but we don't study that one, plasma. We will just study solid, liquid, and gas. In solid state, everyone, particles are packed very closely together. They are very, very close to each other, as you can see in this figure. As you see, they are very, very close to each other. For example, this glass, it's a kind of what? Solid, and it has certain shape and value. Okay, if you for example apply any force on it, you cannot even change its value. So we can say solid has definite shape and definite value. Okay. Okay. For example, glass, wood, paper, pencil, and ice. They are all examples of what? Solid. You see, for example, this wooden block is a kind of solid object. It has fixed shape and fixed value. This pen, for example, is a kind of what? Solid. Look at this book, for example. It is also kind of solid state matter. Okay? Let's continue with even the guys snowman. Snowman is a kind of solid matter. Okay? Solid state. Let's continue with liquid state, guys. Liquid particles are almost as close as solid state. Solid particles. Liquid has definite volume but has no definite shape because it takes a shape of container that you pour into. Okay? For example, you see there is some water in this beaker, right? If you pour this water into the graduated cylinder, this is the graduated cylinder, it will take shape of what? Graduated cylinder. As you see, water took the shape of graduated cylinder. How about if you pour this one into the glass? What's gonna happen? What's gonna happen? Of course, that's right. It will take shape of glass, as you see, right? So, liquid has no definite value. Definite shape. It has just definite value. Okay. For example, guys, water, oil, alcohol, mercury, they are all examples of liquid state. Okay? Liquid. Okay, you see, this is the water, everyone. How about last one, gas state, everyone? Particles are very, very far away from each other. So, in gas state, gas can move from one place to another easily. Okay? As you see, guys, in gas state, in the figure, you see, particles are far away from each other. Okay? Gas has neither a definite shape nor value. For example, air, it has no definite shape and definite value, right? It takes just a shape of container that you put in. Okay, for example, oxygen. You know, oxygen has no definite shape and definite value. If you take a breath, it will take shape of, for example, your chest, right? For example. Yes. So, gas has no definite shape and definite value. Okay, these are the examples of gases, everyone. For example, air, oxygen, hydrogen, carbon dioxide. They are all examples of what? Gas state. Let's continue. Okay, here we have some guys gifts, and just look at the gifts and tell me which one is, let's say, solid, which one is not solid, and also label them as whether they have whether they are matter or not. For example, is the sound telephone is now you see in this GIF is ringing. Its sound is matter or not? What do you say? Matter? No? Of course no. Sound is not matter, right? For example, dog is making sound, right? Is it matter or not? What do you say? No? Okay, very good. Of course, it's not. Its sound is not matter. How about the dog itself? The dog itself. Is it matter or not? Matter? Yes, of course. Very nice. Very good answer. How about the heat? Heat. Matter or not? Of course, not matter. How about the light, guys? Light? Not matter? Of course, very not. It's not matter. Very good. How about the guys? Wind? Is it matter? Yes, it is matter because it is the movement of what? Actually, movement of air particles. Okay. Can you now say, guys, the candle is liquid or solid? Which one? Which state? Solid or liquid? Of course, solid. How about water? Water. Is it liquid or not? Or solid? Of course, it is solid. Sorry, it is what? Liquid. Okay, let's continue. I think you understand this topic. Let's continue. These are the figures about, guys, structure of states of matter. For example, in here particles are very, very close to each other. So which state it shows? Which state? Solid, right? Very nice. This one shows solid state. How about next one, next picture? This is the liquid water. This is the water. And you see particles are almost, sorry guys, let me drink some water. Okay, let's continue. Sorry. Okay, particles are almost as close as solid particles. There is just a little bit space between particles. Okay? How about gas state, everyone? Last figure. As you can see, guys, they are moving freely in the container. You see. Why? Because they are just far away from each other. Particles are far away from each other. So this one is gas state. This one, liquid state. Okay? Let's continue. Here we have, guys, some pictures here. I want to just label each one of them as solid, liquid, and gas state. Okay? Is the air come out of gas? is the gas in a container. Which state? Gas state, right? This is the gas. How about this one? In the cup. What is it? Liquid, right? Coffee is kind of liquid. And how about this crushed paper? Is it solid, liquid, or gas? Which one? Which state? Of course, solid. How about, guys, this one? Is it liquid or any other substance or any other state? What do you say? What do you say? What is your answer? Liquid? Very nice, very good answer. Liquid. Liquid state. Okay, how about this one? Ice. Is the ice solid or liquid? Of course, solid. Solid. Okay, let's continue, guys. Okay, properties of matter. You know, guys, matter has certain properties. Matter has, for example, guys, mass, volume. These are the common properties for matter. Other properties that matter has: boiling point, density, solubility, etc. These are the characteristic property. It means they belong to substance. For example, boiling point belongs to only one substance. It means okay, guys, other properties like boiling point, density, solubility, etc. They are all characteristic property of each type of the substance. For example, guys, you know, boiling point of water is 100 centigrade degrees. This 100 centigrade degrees only belongs to water, okay, not the other substances like alcohol, like mercury, okay, just belongs to water. For example, boiling point of alcohol is 78 centigrade degrees, right? This value just belongs to alcohol, not the other substance, okay? Density also is a kind of characteristic property, also belongs to specific substance. For example, the density of water 1000 kilogram over meter cube, but the air's density, for example, less than water's density, less than 1000 kilogram over meter cube. Okay, let's continue. Okay, every substance has two properties. One is chemical property, everyone. One is chemical property. One is physical property. Let's continue with chemical property, everyone, or let's say chemical changes. Chemical properties are properties that change the nature of matter. It means, guys, if a chemical change happens in any substance, that substance is converted to a different substance. For example, if you burn paper, then it will be what? ashes, right? Ashes. Chemical property just changes the matter, okay? Changes the matter. For example, flammability, acidity, basicity, reactivity with water, burning paper, boiling egg, okay? All change to what, guys? Nature of matter. It means matter will be another kind of matter, okay? These are just examples of chemical properties. Okay, when chemical properties of substance are changed, it means new substance is formed. Okay, new substance is formed. Let's continue. Here is some examples about chemical change. For example, flammability is a chemical property. If you burn something, you cannot turn it back. Okay, you cannot turn that substance back. Okay, or for example, if you burn this paper, guys, it will be totally ashes. Okay, then you will not convert it to its original shape. Okay, for example, the rusting of iron, it is also kind of chemical change. Or for example, baking a cake is a kind of chemical property. Fireworks, for example, or spoiled orange. You see, guys, you cannot eat this orange anymore. Why? Because it is spoiled. It changed into another substance. Okay? It is not orange that you can eat. Okay? Let's continue with physical changes. Okay. Physical properties of substance that can be observed and measured by altering the substance. They can be organized as intensive and extensive properties, guys. What is intensive properties? These are the properties, for example, okay, for example, mass, for example, weight, for example, volume, length, and charge. These are the intensive properties. How about extensive ones, guys? These are just known as intensive properties, known as characteristic properties. For example, odor. Odor is a kind of characteristic property, belongs to specific substance, right? For example, color. It is also, guys, extensive property. Boiling point, also a characteristic property. We talked about this. Density, also kind of extensive property. We talked about this. When physical change happens, the nature of substance, doesn't change. Okay? For example, suppose that you have an apple and you cut that apple into two equal, let's say, parts. You can eat this apple. Why? Because its nature didn't change. Okay? Okay. Original substance doesn't change in physical property. Here we have some examples about physical change, guys. For example, this is the paper, and this machine just cutting the paper, and its pieces still paper, right? Pieces of what? Paper is still paper. Its original, its nature, I mean, didn't change. How about, guys, converting, let's say, freezing water? Freezing water. Is it physical or chemical? Which one? What do you say? Of course, physical, right? If you freeze the water, it will be what? Ice. If you melt it again, it will be what? Water, right? So you turn it to its original shape, its original substance. It means it is physical, right? In chemical one, you cannot change it to its original substance. Okay, broken pencil, guys, is also example of physical change, because if you break that pencil into two, each part is still what? Pencil. And these are another example. This is another example. For example, cutting the apple into two equal, let's say, parts. Chemical properties tells you the types of changes matter can undergo. Okay, this is another example. For example, ice cream is on the ground. Its nature didn't change, so it is kind of a physical property. Okay, let's look at this puzzle, everyone. It's about word puzzle. Guys, I will solve one of them. The others will be your homework. Guys, some terms we studied today. For example, matter, right? Extensive, extensive, this kind of words we studied. I want you just each word and explain each of them in your own guys explanation. Okay, let's solve one of them together. For example, just wait. For example, intensive. Where is intensive? It is here. Intensive. Okay, this is the intensive. Guys, what was the intensive? It is the common property of matter, you know, and we explained it as for example, as mass, as value, as weight. Okay, blah blah blah. Okay, let's next topic is measurement, everyone. We are going to now learn measurement. Okay, guys, what is the measurement? What comes to your mind when I say measure something? What can you say about the measurement? What comes to your mind? Numbers? Just numbers? What else? Just numbers? Of course. Numbers and units, right? So, what is the measurement? Describing things with numbers and unit, right? Very nice. Describing something with unit and numbers. Very good. You know, everyone, before the international system of measurement, you know, people were using different kind of things to measure what things. For example, to measure the land. For example, to measure the land, people were using handspan, right? Handspan. For example, this book is just a 1.5 handspan, right? They were also using for example, rope to measure, for example, long distances or long things. For example, to measure size of this classroom, length of this classroom, they were using step, for example, as 1, 2, 3, 4, 5, blah blah blah, right? But now people using different. Okay, guys, let's see. The new topic is measurement, but we don't have enough time. Lesson will finish. So we are going to study measurement next time. We are going to cover this topic next time. Okay, just tell me what we learned today in this class. We learned matter, and we defined matter as anything which has mass and value. We also discussed the states of matter, right? For example, solid, liquid, and gas. We defined solid, liquid, and gas states, right? We also discussed about what properties of substance as what physical change and chemical change, right? Okay, very nice, everyone. Thanks for your participation. Take care of yourself.